All right, so ClickHouse for AI and ML. As we all know, I guess, no startup conference in 2025 is complete without some sort of AI strategy presentation. Thanks for bearing with us all the way to this point. We'll try to keep this relatively light. But anyway, this, I guess, AI fad makes sense. VCs have invested hundreds of billions of dollars into AI in the past few years, and the ecosystem is growing faster than anything I think any of us have ever seen. I really like the word ecosystem here because, for the most part, each I guess, organism in the AI space falls into one of two categories. On the one side, you have companies producing and providing models. So Modal, for example, is kind of providing models. And on the other side, we have companies consuming AI model outputs in order to do something. At ClickHouse, I think kind of uniquely somewhat, we found ourselves in this position where model providers are using us to train and observe their models, and consumer companies use ClickHouse to store and fetch data for prompt enrichment and power agent-facing analytical experiences. So in other words, I like to think of ClickHouse as having some kind of symbiotic relationship with the entire AI ecosystem. And I guess in support of this symbiosis narrative, I'm going to show you some cool features we've been working on the last year or so. All right, so first up is UDFs. Personally, this is hands down one of my favorite ClickHouse features. Anything you can't easily write in SQL, you can literally write in any other language, registered as a function within ClickHouse. You pass in inputs via standard in, you catch them back on the other side via standard out, and that's about it. If you can think, there's lots of use cases for this, but notably, a lot of large financial services and trading firms use UDFs to model out like their risk models that their data science teams are writing, or I guess predicting securities prices over time. And this is obviously not easily expressed in SQL, and these data science teams really just live in Python notebooks. But we need to somehow get that, I guess, code into ClickHouse, right, so it can run against large financial data sets in real time. So that's kind of one use case. But I guess more relevant to today's subject, UDFs unlock a key piece of functionality for AI/ML workloads. Communication with models. So let's say you want to actually send some string and get a response back from a model to enrich your data. Let's say you want to generate vector embeddings on the fly as you're ingesting analytical data. This is all stuff that UDFs support. ClickHouse has actually supported UDFs in open source for many years already, but today I'm excited to announce that UDFs in cloud are officially in private preview. This has represented a very, very tough engineering challenge for folks at ClickHouse. Obviously, anytime users are running their own code in your multi-tenant environment, the vulnerability vector increases. So we've had to tackle some challenges around isolation, et cetera. Embeddings generation is great, but what about actually storing these embeddings afterward? And what about search? Using ClickHouse as a vector store has already been possible for quite some time, but we're missing an important feature where we were, and that is vector similarity indices. Excitingly, this is now officially generally available. Currently, it uses the HNSW approximation method, and it currently supports Euclidean and cosine distance comparison functions on top of that. So as I see it, this is like almost a very localized example of that same symbiosis. You can generate these embeddings on the fly for your analytical data, and then at prompt time, your application can leverage vector similarity indices to retrieve relevant records super fast, and then perform analysis on top of it. Maybe as part of a RAG pipeline, maybe for a recommendation engine. The sky is really the limit here. And just to demonstrate how this all comes together, I've got a quick demo. So here's our ClickHouse Cloud Console. And as you can see, I've got this basically just super simple embeddings generation UDF. It's making a call out to OpenAI's embeddings model, and it's allowing us to kind of return a vector embedding for any string we input. So right now we've got ClickHouse is cool, and if I go ahead and run this, you'll see very quickly it kind of returns a 1,500 plus dimension vector embedding resulting from this string. But taking this one step further, obviously, just generating one embedding is kind of cool, but what's really cool is generating embeddings for an entire analytical data set. So here we've got the Hacker News data set enriched with embeddings generated from concatenating the title of a post with the body of the post. And we've done this for cost reasons here, just 10 million rows, but it's enough to, I guess, represent a good demo. And so we can do cool things here, like let's say we want to go find Hacker News comments that are similar to ClickHouse's cool. We can generate this embedding on the fly, and we can search through all of our vectors to return similar comments. Here we can see ClickHouse is good, ClickHouse is another option, ClickHouse is house, ClickHouse is very cool project. I agree with all this stuff. So taking this one step further, obviously even just showing you in the IDE really isn't super useful, but how does this actually manifest itself in a real application? So to demonstrate that, we've kind of built this very simple web application on top of this Hacker News data set. So we'll kind of come in here and type something random, let's say bfloat16, and we'll perform a full text search for this string, just I like against the whole table, just to get a baseline set of comments here. So here we've got some, I guess, relevant comments. No surprise, because it's full text search. But now let's go see relevant comments, and we'll use vector search to do this. And you'll see this run will be very slow. And that's because if you've noticed over here, I've got this set to non-index. So I'm running this against the full data set without an index included. So as you can see, it does a full scan. It reads all 10 million rows. And that takes about 4 seconds to run. But what if we make this indexed? As you can see, it doesn't need to scan the full data set anymore. We're only reading a small fraction of those 10 million rows. And the execution time dropped from 4 seconds to 211 milliseconds, it seems like. Anyway, this is just one of many things. And we could keep playing around this forever. But I think I don't want to hold you guys from drinks too much longer. So if we can go back to the presentation. All right. So going back to model producers and provider side of the ecosystem, as I mentioned, ClickHouse is already used by many companies as an offline feature store for model training and fine-tuning. And beyond that, we actually also provide a suite of tools to help ML researchers and engineers explore and prepare data sets before they're used to train models. So think CHDB for within your Python notebooks. It's kind of an in-process version of the ClickHouse query engine. It's really just meant for use with Python, Ruby, et cetera. It's all in process. We've also got ClickHouse Local, which is just a very lightweight local client of ClickHouse, bundled very, very tightly. And I think many of you, if you've come to any of our meetups in New York, have seen Alexei's How is the AI Made talk before. I can't begin to even replicate his delivery there. So if you want to check it out and you haven't seen it before, just go on our YouTube channel. It's 15 minutes well spent. It's super funny. But just to illustrate really quickly the overarching point here, here's a quick video from this presentation of Alexei showing token usage comparison between Blue Sky and Hacker News. And you can see he's crunching through 1 billion rows in just over a second. So that's kind of the scale at which ClickHouse operates to kind of help ML researchers explore and prepare these data sets before they use them for training. All right, so speaking of speed, the final piece of the AI equation to unpack is how ClickHouse supports these increasingly complex AI agent workflows. But in order to do that, we need to first agree on what the analytics/analyst workflows look like without agents. So without agents, the way to interact with a database looks something like this. You begin with a blank canvas. First, you need to understand what kind of tables you have access to. Then maybe you start running some exploratory queries to understand the data. And start to iterate deeper and deeper and so on. And so, say you are a data analyst and your boss gives you an open-ended question. You could spend all day long just writing queries, grokking whatever it returns back, and then conceiving of what the next question you need to ask is. And this is great if you're already a database person and you speak SQL. It's fast, it's very responsive. But what if you're not one of these people? What if you just have questions? What if you want to level up your efficiency? All of these are valid questions. In this user-facing analytics paradigm, users interact directly with the system. They submit these queries, they receive results. There may be some middleware, but still one query equals one set of results. In an agentic workflow, the difference is that you express a question that triggers an analysis. And this was really made possible by a new generation of reasoning models that introduce thinking capability for models. And that's been a huge unlock for agentic workflows. So the modalities changed a little bit. One question or prompt now potentially triggers 10, 15, 100, 1,000. We don't really even know how many queries. It mostly depends on the complexity of the question. Anyways, on the database side, the system is constantly and sequentially bombarded with queries based on the initial prompt. Think about this for a minute. Let's say the underlying database isn't ClickHouse. We won't name any names, but let's assume this alternative performs at, let's say, minute scale, not millisecond scale. One question equals 15 queries equals 15 minutes. So the experience isn't interactive anymore. So as it turns out, the same characteristics that make ClickHouse a suitable database for user-facing analytics also make it a very suitable database for agentic workflows. There's good interactivity, high performance querying capacity, low latency, the ability to accept high volumes of concurrent queries, and serious read-write throughput. These all help position us in a very interesting way. And as a result, we haven't needed to adjust very much for the agentic AI era. The core functionality is already built. So now we just need to stick an agentic layer between ClickHouse and the user. And this agentic layer can trigger a lot of queries, even more if we start to consider potential autonomous agents moving into the future. So with all this in mind, let's take a look at something new we've been building to demonstrate how powerful this ClickHouse plus AI agent combo is. I'd had a recorded demo, but Tanya used it earlier in her presentation, so we're going to do a live one instead. So bear with me here. Cool. So this is another big data set, a few orders of magnitude larger than the Hacker News one. It's GitHub event data, 3 billion plus rows. And we are going to ask our Ask AI agent a question, just to get some information about open source ClickHouse repository, show us some cool stuff. And as you can see, that kind of blank slate I guess, behavior that you might have as a user facing your analytics goes away immediately. The agent will immediately go look at what tables you've got, explore them, understand them, and immediately start running queries against them. And it can do this so much faster than a human being. It's honestly incredible. And as you can see, we're iterating through different steps here. It's reasoning as it goes, trying to figure out what angles it's got. And we'll just let this run for another minute. And it can even spit out cool charts. Depending on the model, by the way, we're using Sonnet 4, so it's a little bit more lightweight, but if you stick Opus or something behind it, you'll get verbose, like MBA level analyses in like less than a minute, which is pretty crazy. And unsurprisingly, Alexey Milovodov is a superstar contributor to open source ClickHouse. Anyway, this is kind of just, I guess, the drop in the bucket of what this new Ask AI agent is going to be capable of doing. It's still in beta, and you can use it today from the ClickHouse Cloud Console. So if we can go back to the presentation, please. So, oh, there we go. Obviously, what you just saw in our Cloud Console is a great tool for folks who are actively managing clusters in ClickHouse Cloud. But this is only a small slice of the pie, because our customers aren't and shouldn't be onboarding their entire employee/workforce base into the ClickHouse Cloud Console. Realistically, they're either building dedicated internal tooling, we also have this, or applications for their downstream customers to interact with data in ClickHouse. And this is where MCP comes into play. So I'm sure everyone in this room is already aware of what MCP is, but it was announced in November of last year. And as a first act, just a couple months later, we released our open source MCP ClickHouse repository. This is basically a self-hosted MCP server that can connect to any ClickHouse anywhere. But obviously, batteries aren't included. You need to deploy this and maintain it yourself. You need to input your credentials, and you need to kind of, I guess, shield it from the broader internet should you choose to do so. So with that in mind, we move into, I guess, Act 2 of the ClickHouse MCP story. And that is our remote MCP server within ClickHouse Cloud. This comes with batteries included, as you might guess. You get OAuth authentication out of the box. You just use a single connection string, and it's compatible with all of your favorite tools like Claude Code, Cursor, and the like. So what does this look like in practice? Here's like a quick recorded demo this time, kind of demonstrating how this all looks. It's as simple as going and choosing a different connection protocol for your ClickHouse Cloud cluster. There's an MCP one, you enable it, and you immediately get a connection string that can then be loaded into your favorite tool like Cursor. And so here we've already kind of skipped the loading step, obviously, but you can see we've got a basic Next.js application with React on the front, and it's querying ClickHouse for some charts. But I guess importantly, now we can ask the Cursor agent ClickHouse-specific questions, and it has direct access to your underlying ClickHouse service. And this is the same prompt that Tanya, I guess, used earlier in her video demo, but more or less it's just a cool data set to play around with for eye candy charts and the like. And I guess one step further past just outputting results here, we can also integrate this straight into actually code generation as well. So once you've iterated on a query with the agent, you can have it build React components that directly actually source their data from these queries that they are generating. So I don't think we need to watch the rest of this, but the gist is effectively that. All right. So I guess from anything from like all over the AI ecosystem, you'll find ClickHouse. We're used to train the models. We're used for AI-powered data enrichment. We're used as a vector store for RAG pipelines, and we're used as a backend for agent-facing analytics. In other words, we are the database of the AI era. So with no further ado, I guess I'll hand it back over to Zoe, and then we can go for some drinks. Thank you all so much.